Okay, great. Thank you. Good afternoon, everybody. Thanks for attending. My name is Brian. This is Erik, and we are from Send Safely. And today we're going to talk about our experience implementing content security policy within our website at sendsafely.com. So just a quick show of hands, who in the room is familiar with CSP, CSP being short for Content Security Policy, and we'll just call it CSP from here on out. I see a good number of hands. We're not going to spend too much time today talking about what CSP is, but we are going to give just a quick primer in case you're not familiar with CSP. Essentially, CSP is a new directive that you can use as a website operator to control how content is loaded from the browser when people are visiting your website. It can control the location of where the content gets loaded from, as well as to some extent in different categories of content what that code can do. And when we talk about content, specifically we're talking about markup code, so code that's being run by the browser. And really the main purpose of CSP is to help prevent against a whole series of vulnerabilities that are typically categorized as content injection attacks. And of course there's one very well-known content injection attack that starts with an X. Any guesses? Or with a C technically, but cross-site scripting, XSS for short. So when we decided to implement content security policy on our website, cross-site scripting was of course the main threat vector that we were trying to contain. But what we recognized was that, what content security policy isn't, and the most important thing to take away from this talk is that, CSP is not a silver bullet for preventing cross-site scripting. So it's not just some sort of magic solution that you can sprinkle on your website and cross-site scripting just goes away. If anything, you need to think about CSP in terms of being a safety belt, that in the absence of some sort of output encoding or input validation on your website, provided you're trying to do this consistently across the board and you miss a spot, it may save you. But you certainly don't want to rely on CSP as your primary defense mechanism for something like cross-site scripting. Just to give you some background on CSP, it actually started back at Mozilla and has now grown into its own standard that's managed by the World Wide Web Consortium, or W3C for short. Version 1 is still not final, but it's in the final stages of the release candidate phase and should be finalized very soon. And support for version 1 is pretty good across several of the major browsers. There's already a version 1.1 spec that's in draft. That does not have widespread support. It's still in the draft phases. So for purposes of our talk today, we're going to focus on CSP 1.0 because from a practical perspective, the browser world is just not there yet if you want to implement CSP 1.1. So everything we talk about today, when we may mention things that are coming in 1.1, we're focusing on the 1.0 standard. As I mentioned before, browser support is fairly good in the major browser families, with the exception of Internet Explorer. So we've got the different versions of the major browsers that support CSP. IE is not there yet. They do implement some features of 1.1, but really they don't implement any part of 1.0. So for purposes of our talk today, while Internet Explorer is almost certainly going to be implementing 1.0 in one of their upcoming releases, I don't know what the timeline is on that, and currently none of the versions that are out there support the standard. But every other browser does support it. As far as who's using CSP, like I said, it's still in draft form, even though a lot of the browsers are supporting it. So as you would expect, not all that many websites are using it. There was a survey by Veracode a few months back, actually probably 6 months ago, where they looked at the top 1 million websites and found that only about 200 or so were implementing CSP in some way, shape, or form. The good news, though, is that a lot of high-profile names are in that list. So it is definitely a standard that's getting traction. A lot of the major players are leading the way in implementing it. So we do think this does have legs, and it is going to become one of the standard security protocols that websites use going forward. Without going into too much detail on each different category of content, we've got listed up here the major categories of content that CSP can be used to lock down. And what we're going to do throughout our presentation today is we're going to run through the the decisions that we had to make with respect to locking down each of these content categories, and we'll talk about the directives that we've implemented and what we've done with respect to each of these categories as we go through our presentation today. So we'll keep coming back to this list here as we go forward, but this is really just more of an opening reference. As far as the ways you can restrict content with CSP, the main way that you restrict each of those categories is by the source of the content. So you can specify for JavaScript, for example, where can JavaScript load from. You can say don't load any JavaScript. You can say load it specifically from our own website and no other site. Or you can even whitelist specific host names or domains that you want to load content from. And you can even go as far as defining a wildcard there to say allow this content from any source. Now, certain categories of content will actually allow you to go a little bit deeper, and we'll talk more about this when we get to those categories, but specifically they can control different subsets of that category. So for JavaScript, for example, there's a family of functions that you can ban. There's also the practice of having certain inline variants of these code categories within your content. And then a very important point here that we've got at the bottom is that if you don't want to go ahead and define these categories or these policies for every single category, you can simply specify a default policy for your site and then specify exceptions to that. So typically if you don't specify a default source, that it's going to be left open as a wildcard. So by default, CSP says allow anything, and you can then start locking down specific categories, or you can actually say allow nothing, and then you've got to actually loosen the policy on a per category basis. And again, we'll go through examples of how we've done that in our website. So before I hand it off to Erik to talk about the first and main category of content, which is JavaScript, I want to just provide a little bit of context to our application because it's going to be important as we go through our thought process here today. So at Send Safely, we have of course, it's a web application. So we have a web front end that's very typical of most web front ends. We've got HTML, JavaScript, CSS, and so forth. We've also got a series of APIs and an Outlook plugin that consume web services, but since those interfaces are not browser-based, when we talk about CSP, we're going to really be focusing on the left side of this picture here. And specifically, in addition to just the standard HTML and JavaScript and CSS that you would typically find on most websites, there's a couple notable exceptions that we'll have to make different decisions with respect to as we go through our policies here. Specifically, we use reCAPTCHA in certain cases. So reCAPTCHA is going to be a third-party site that our users are going to have to interact with using their browser when they're on our site. So that's one thing we'll need to consider. And then we've also got a couple pages that do, so just some background, we're actually a file transfer platform, and some of the pages on our platform that do a lot of heavy lifting with respect to our file transfer protocol have to do their work in either HTML5 using the File API and web workers, or for older versions like IE8 that doesn't support HTML5, we have a Java applet that we run. And everybody knows how much we all love running Java applets. So we'll talk about some interesting challenges we had with respect to that as we get to that category. So that's just a little bit of background on our website. What we're going to do now is really introduce the main framework for our conversation today. And it really is going to walk through our strategy for implementing CSP. And we really had three main objectives when we looked at why we wanted to implement CSP. The first was that we wanted to be as strict as possible. So even though XSS was one of the primary threat vectors, we wanted to go ahead and address as many threat vectors as we can with our policy. The other thing we wanted to do was make sure that if there are attacks that are actively trying to happen on our site and our content security policy blocks them, we want to be notified of those attempts. And there's some built-in features of CSP we can use for that. And then the last objective was to really maximize browser coverage. So when we talk about CSP and we talked about the different browser families and their support for CSP, there are some nuances that we need to be aware with when we're implementing CSP. So we're going to walk through each of these objectives in detail, starting with the most important one, which is going to be defining our strict CSP policy. So what I'll do now is hand it off to Erik, who's going to kick off that section with JavaScript, our favorite
All right.
category of content.
So just as Brian mentioned, now we know a little bit about what a policy is and what it's used for. We're going to actually talk about how we implemented ours and how we locked it down as much as we possibly could to eliminate cross-site scripting. So, but before we do that, I just want to show you a quick picture of what our site used to look like before we implemented our policy. And it's a very typical web server. We had our HTML, our CSS, and more importantly, our JavaScript all bundled together on one web server. I'm sure that's very similar to all of your web applications look like as well. So that being said, let's talk a little bit about our policy. So we wanted to go ahead and we wanted to use what we call the deny by default model, which pretty much means that we want to lock everything down and then we just want to open up those specific things that we need. So we went ahead and we set our default source to none, meaning that now everything is blocked. No JavaScript is going to execute, no CSS is going to render, nothing. So our next step was to move all our JavaScript onto a static server. We didn't want to load them from our own web server. We wanted to move it all out. So we only had to allow JavaScript to load from this server and not even from our own web server. So we went ahead and did that. And now, of course, we had to add this static.sendsafely.com server to our policy as well. From here on out, we're going to call the server just the static server. And lastly, we wanted to, of course, we wanted to avoid inline scripting because that's really where all your cross-site scripting issues are introduced. So we wanted to avoid that. So we really had to migrate away from all our inline scripting out to our static server. We're going to talk more about that in a bit. And additionally, we didn't want to allow any string to code functions such as eval or set timeout to run. So this is really what our servers look like today. We've kept the main web server, which still holds our HTML code and our CSS, and then we created our new server, which hosts and where we load all of our JavaScript from. So that was pretty easy. All we had to do was move our JavaScript files onto this new server, and we were pretty much done with that. So now we're going to talk about what we actually did run into some problems with, and it was mainly migrating our existing JavaScript code base. So we already knew before doing this that using eval is not the best thing to do. So luckily we had already banned that. So we didn't really have to make any changes to be able to get rid of the unsafe eval operation. We did, however, have a lot of inline JavaScript in our code. So that definitely took some work to get rid of. And I'm going to show you a few examples in just a second of what we did. So it turned out to be, we dig down and we started looking at our JavaScript code, and we could see a few simple patterns that we followed throughout our applications, and I'm sure you guys are going to recognize it as well, because I think it's one of the more common patterns. And just by finding a solution for those two patterns, we could really move away almost all of our JavaScript code right there. So let's take a look at the first example. It's a very, very typical example. You have a link or a button, and when that is clicked, it's going to call a JavaScript function of some sort. Now, as you can see, this is definitely inline JavaScript, which we just can't allow. So we had to find a solution for this problem. So we went ahead and we removed the JavaScript, of course, and instead we introduced a unique identifier into the tag, in this case called myLink. And by doing that, we could reference this link from JavaScript instead and create kind of an object referencing that link. And then now we can just add an event listener that was registering on a click, and when that event handler executed, it would just call our do something function. So this last part we could of course put on our static server instead and keep our HTML clean from JavaScript, and instead just trigger it from our JavaScript files. So our second example is similar, but a little bit more complex. This time we have a text field, and then we want to do some kind of action every time someone presses a key. And besides from that, as you can see, we also take in 2 arguments into our function this time, which introduce a new level of complexity. So yet again, we remove the JavaScript from the code, and we introduce our new unique identifier called myEmail field in this case. And As you can see on the second row here, we have 2 data arguments, which is actually a new HTML5 feature as well, but luckily it's something that's been in there for a while. It was one of the first features to get adopted, so even IE8 and up supports it, which is great for us. But what it can do is it pretty much gives you the opportunity to introduce your own attributes into a tag, so you can put whatever data you want in there, which is great. We use this throughout our application. So in this case, we of course we throw our arg1 and arg2 in there. And let's take a look at our JavaScript. So yet again, we reference my email field from JavaScript instead. And this time we use the key up event handler instead of the click as before. And we can call do something else from in here, the function. And as you can see, we can easily reference these data attributes from JavaScript instead, and thereby pass those into in as function arguments. And in this example, we use jQuery to do this, just to make the code snippet a little bit shorter. But of course, it can easily be done without any third-party libraries as well. So that was really all we had to do to migrate our own code. But unfortunately, we are depending on some third-party scripts, like I'm sure you guys all are. And mainly we want to talk about jQuery and reCAPTCHA here. Our policy is to host all our JavaScript on our own servers. So we don't have to be relying on jQuery being online. Instead, we can just host it ourselves and load jQuery from there. So by doing that, we don't have to open up our content security policy to jQuery or to whatever library you want to use. And we can still stick with our static domain. However, we did run into some problems with reCAPTCHA, because jQuery ran pretty smoothly. We just threw it up on our server and it worked fine. reCAPTCHA, however, in case you didn't know, actually, while you can host the base reCAPTCHA file on your server, once it executes, it actually tries to load some content out of the reCAPTCHA server. And it's basically a challenge response system, so it's not really something you can download yourself, because it changes every time and it's dynamic. So we did have to loosen up our policy a bit to actually allow reCAPTCHA to load. And as you might know, reCAPTCHA is owned by Google, so it's actually hosted on Google's domain, so we had to allow google.com. Although that's not something we're thrilled about, we do recognize that Google is still a pretty trusted server, so we were okay by doing that. And then actually CSP 1.1, which is currently being specified, is actually going to allow you to limit down the content by a URI as well. So potentially we could just allow google.com/reCAPTCHA, which we can't really do today, but in the future. So we did that, and we fixed that part at least. But then once we tried to use reCAPTCHA as well, we did see that some errors were triggered, because in the reCAPTCHA code, what they do is they actually render out some code into your HTML page, and that code contains some JavaScript. So yet again, we had to deal with this unsafe inline. And not even that, they also had I think 2 cases of where they used eval as well. And so we had to deal with that. But it turned out that although we know it's not the best thing to do to start digging into the third-party code, we really didn't have an option, because we were not comfortable with opening up ourselves for unsafe inline and unsafe eval, because then what's the point of having the policy in the first place? So we went ahead and we started looking at the code, and by the way, I should say that once we fixed this, we reached out to Google, and then they actually worked with us to fix it. So now if you go ahead and download reCAPTCHA, it's gonna be compliant with content security policy without using eval and inline scripting. So we're gonna look at one example here, which is an example of where they used eval. So in case you didn't know, setInterval actually, in the first argument here, you can choose to either pass in a string or a function. And if you pass in a string, it's pretty much going to be run through eval and converted into executable Java code. So I mean, in our case here, all we need to do was to convert this first code snippet into a function instead, which of course was pretty much end up just removing the single quotes, and then and we no longer had to use eval. So that was actually pretty simple. And then the other two instances we run into were very similar to the ones that we discussed before, so I'm not going to go over them. So the last thing I want to talk about when it comes down to JavaScript here is web workers. So as Brian mentioned, we have to use web workers on 2 of our pages, mainly because we do some heavy file processing. And if we don't put in workers, our UI is going to freeze up, and eventually the browser is going to hang. So web workers are enforced by the same origin policy, so we can unfortunately not load them from our static server. Instead, we need to host them on our main web server. So luckily our policy is dynamic enough, so we can only open up the self attribute in just those 2 pages and restrict it to that. And it's actually interesting if you think about it, because the same origin policy in the first place is there to increase the browser security, but now all of a sudden it forced us to open up our policy and thereby increase our risk a little instead. So that being said, now we've talked about our default directive, which we block everything, so it's default source none. And we talked about our JavaScript directive where we need to open up our static server and also google.com. That being said, I'm going to leave it over to Brian again, who's going to talk about the rest of our directives here.
So as you can see, we went through a decent amount of effort to refactor our existing code because, again, like many applications, this site was not built with CSP in mind from day one. When it came to the style sheets category, one of the first things we realized is that much like JavaScript, and even more so than the JavaScript category, we had a ton of inline CSS everywhere. So we knew off the bat that if we were going to go through and try and eliminate the unsafe inline code for the CSS category, it was going to be a lot of work. The other thing, so immediately this was one of those areas where we said, okay, given the fact that we're trying to be as tight as possible with our policy, but we also don't want to just go crazy and start refactoring everything for the sake of it. So we really had to think about the cost benefit here and the risk reward of actually refactoring the CSS code. So the first thing we looked at was, given the state of affairs, without touching our CSS code, what do we need to get the code to run as is? And when we did that, we realized that we have to allow unsafe inline, which, coming from the JavaScript category right before this, we realized that unsafe inline could really expose us. And even the fact that the word unsafe is in the directive makes you kind of think to yourself, should I really be doing this? So we did a little more research just to really make sure we understood the threats well. And really, at the end of the day, the unsafe inline directive is going to potentially expose you to CSS injection, but it's still not going to expose you, in most cases, to direct script injection. There are some attacks, and we're not downplaying the CSS injection threat vector, but it's nowhere near equal, in our minds, the threat of direct script injection through unsafe eval or unsafe inline with respect to JavaScript. The other important thing here, which is an important point that maybe we didn't harp on with JavaScript, is that we are not relying on our CSP, as I mentioned before, as a primary defense mechanism for anything. We have a very robust encoding API. It's actually built or based off of the OWASP ESAPI encoder. So it's got context-specific encoding. We're, to the best of our ability, making sure that we encode and validate everything that's coming in and going out of the application. So really, the fact that this wasn't our primary defense mechanism and the fact that we knew it was going to be a major undertaking, we decided for this category that we were going to go ahead and kick this can down the road and table this for the next round of lockdown for our policy. And maybe when we go to refactor the UI, we're already going to be working in the UI. We can think about this threat at that point, but for now, we're willing to live with this risk, or this threat, I should say. So, going back to our policy, the style sheets category, the style source, we left as defined as our self and unsafe inline, and we really didn't have to do anything to our CSS code. There's a little more work to be done there down the road, but for now, we're leaving that category alone. The remainder of the categories were not nearly as challenging as JavaScript or CSS for us. And this may be very well may be true for most sites out there. When it comes to the connection source attribute, we're using this connection source is really used to restrict where you can connect to with things like WebSockets or XML HTTP requests. And for the most part, we're only dealing with connections back to ourselves. So we defined that attribute as a connect source value of self, and everything continued to work as is. There was really no refactoring needed there. Similarly, when we came to the frame source category, there are a couple pages on our site that do frame other pages on our site. And if you think about frame source, how many folks here are familiar with the Xframe options header? Okay, so this is not trying to control the same threat that the Xframe options header controls. If you think about that header, it prevents other sites from framing you. The frame source attribute on CSP prevents you from framing other things. So it's really a complement to Xframe options and not a replacement for that. And to that extent, we do recognize that we have some pages framing ourselves, so we define that attribute with the source of self, and everything continued to work as is. Was there a question in the back?
Yeah, related to that exactly comment. So do you have a slide on the tech?
We don't have a slide on that, but we actually control that through Xframe options, and we actually use Xframe options header, and we don't allow any other site to frame ours.
And what was the difficulty actually in implementing that? If you say have a site like CNS?
So we don't allow anybody to frame us, and we don't frame anybody else. So from our perspective, it was an easy problem to fix. Yeah, if we had a requirement where somebody needed to frame us, that's where it becomes a little more challenging. There was actually a good talk earlier today that included some talk around Xframe options, and most of the newer browsers are now supporting, I believe, a frame source directive on Xframe options that let you whitelist what sources, what websites can frame you. But previous to that, it was basically self or none, and we have ours set to none, which doesn't affect us. Yeah, and the question was, does jQuery offer a library for that? It may, but it's going to be done with JavaScript. So I think if we can get away with using a header instead, that's always better. But yeah, for us, it wasn't a major issue. And then continuing down the list, so images. This was, again, a very easy one for us. We only load images from ourselves. The exception to that, of course, as Erik mentioned, was reCAPTCHA. So you can see we've whitelisted Google's domain there. And it also is worth pointing out on both of those directives that we've included Google on. Those directives are protocol specific. So we're only allowing images and scripts to load off the HTTPS URLs on those domains. So this also buys us some good protection, even though we're also using strict transport security, which again, we're not going to talk about today. This also prevents us from having any sort of mixed content bugs with respect to pulling content off of those sources. Web fonts and audio and video, we don't actually have any of those in our site, so those were no-brainers for us. If you do have those categories, it's very much the same thought process, looking to see where you're loading them from. Web fonts are probably one good example of where you're probably loading it off of somebody else instead of your own server, but really just whitelisting those domains. But for our perspective, we don't use those, so we don't even have those in our policy. Because our default source is none, that automatically means that web fonts and audio and video, if we don't specify a media or font source, those are set to none. The last category, which is the final category on our list, is embedded objects, which includes things like plugin resources. So if you think back to the initial context that we provided on our website, I mentioned before that for better or worse, we've got a Java applet that runs on certain pages on our site for legacy browser support if you don't support HTML5. So one of the things we had initially planned was we're definitely going to need an object source here that's going to control where the applets can load from. The question was, can we load it off of our static server, or is that going to break same origin policy and we're going to have to do the same thing for web workers and load it off of our own server and make an exception? So the process that we followed for locking down each of these categories was, since our default source was none, we started with that, we'd load the page, and then we would basically start loosening things up to see how far we had to go until we can get things working. So without adding an object source, we went ahead and loaded the website, and the interesting thing was that the applets actually ran. And we had a default source of none, and we didn't have an object source, but we went ahead and added an object source of none. And in Chrome, Firefox, and Safari, there was no blockage occurring with CSP, specifically when we were loading the applet using the applet tag. So we started thinking to ourselves, maybe there was something we're missing here, and kind of our head exploded for a minute, but then we realized, if all three browsers are doing it, there's probably a reason why this is happening. So we started a thread on the public web AppSec mailing list on the W3C website, And as people started chiming in that were familiar with CSP and people involved in the spec, as well as developers for all the major browsers, eventually the thread started fleshing out that this is definitely not the intended behavior and that this should not be happening. There's still, I think, a little bit of confusion as to why this is happening, and I think it was a combination of different assumptions that were made by different browser vendors. But currently, as it stands, the solution that we've come to is that right now with CSP, there is no way to stop an applet tag from running, and this is definitely not the intention of the spec or the browser vendors. So this is probably going to be something that gets patched at some point in the future. The thread is actually still active on that mailing list, so we still don't have a real clear picture of what the course of action is for this. But we will probably write a dedicated blog post about this on our blog in the next week or two, because this is actually something that we just kind of fleshed out as we were leading up to the presentation, and then realized that that it wasn't something that we were missing, that this just wasn't the way it was supposed to be working. Yes?
Is there a browser that supports CSP but doesn't support HTML5 stuff?
Is there a browser that supports CSP but doesn't support HTML5? Maybe older versions. It's tough to say, because with browsers like Chrome, for example, they've been supporting a lot of this stuff in some way, shape, or form for a while. So I think you'd have to go back to versions of the browsers and see maybe when they started supporting one or not the other. I don't know the answer. I know most of the modern browsers, if they support one, they support both. But the applet tag still works, even though it's technically deprecated. It still works in all the major versions, and is specifically called out in the CSP1 spec as being an element that should be blocked. So that rounds out our content security policy. As you can see, we left embedded the object source as blank because we don't need it. But that being said, I think as we start following what happens here with that, we're most certainly probably going to have to add something back to keep our applet running to prevent it from just breaking when a new version of one of those browsers comes out. But for now, in the initial policy that we created, we left it blank. So what I'd like to do now is, now that we've rounded out the discussion on sort of our approach to building a strict or a reasonably strict content security policy, now we want to move on to our next objective, which was monitoring bypass attempts within our policy. And I'll turn that back over to Erik.
All right, so now when we implemented our policy and we went ahead and deployed it, and as Brian mentioned before, this is really our second defense for cross-site scripting. We already have a pretty strict encoding library. So of course, would be very interested to see if our policy was actually triggered at some point, because that might mean that there is a cross-site scripting vulnerability in our application, and that we want to know about that so we can implement a fix for it that will work across all browsers, since Internet Explorer, for example, doesn't support the content security policy. So luckily, this is something that's pretty easy to do. CSP actually comes with a directive that it's a built-in feature to report back violations. So once they happen, you can specify a URL or URI, and the browser will actually send up a report to you containing some details about what page this happened on, what actually happened, and maybe even a code snippet showing what the payload was. And this is really something that's good to have during development as well, because you can kind of test out your policy and browse around on your application, and you can see that if you get these reports back, you know that you have more work to do before you're actually done with this. And additionally, you can also run CSP in just a report-only mode, where you specify your policy, and the browser will report back the violations, but will actually not prevent them from happening. So this is an example CSP report, and I'm just going to walk through it quickly, and whatever line does. So the first document URI will just tell you on what page this happened. What page is the page that has this cross-site scripting vulnerability. The referrer will tell you where the user came from. So this might be google.com if they just searched for SimSafely and clicked into us from Google. Or in this case, it might show you, if you have a reflected cross-site scripting vulnerability, it will show you the malicious site that actually set up the payload that's used to target us. The blocked URI just says self here, but it might say something else if this injected JavaScript is actually trying to load content from somewhere else. The violated directive, pretty self-explanatory. It just shows you what's going on. In this case, we have an inline script vulnerability, but it might also be eval being used in an external JavaScript file or something like that. The source file will show you exactly what file this is happening in. So in our case, since it's an inline script, it's going to be the same as document URI. But if you had this eval in a different JavaScript file, it's going to point towards that instead. And finally, the script sample. Of course, it shows you just a code snippet of what's actually happened. So in this case, there's seems to be a reflected cross-site scripting that shows you the cookie or prints the cookie.
So to get that report from the browser, you have to specify the URL that the browser sends it to. Do you have any concerns about that it might be used by malicious threats or flooding reports or anything like that?
I mean, that is a possibility. And I mean, of course, when the attacker actually figures out this payload, he can easily just block those from reaching us. But once he actually shows, uses this in production, other people that doesn't know that they should block the reports are not going to do it, so then we're going to see it. But yeah, this wouldn't prevent an attacker from actually finding the vulnerability in us, but hopefully once it's been exploited, we can detect it. So this is an example of a real error report that we've seen on our log files. So you can see it's happening on our auth page, which really is our login page. The referrer is coming from Google, so someone probably searched for SimSafely and found us and just clicked the link. Again, this is an unsafe inline restriction, so there seems to be some kind of injected code on our HTML page. The source file here is interesting, and we're going to talk about that in a bit because it actually seems to be pointing towards a Chrome extension. And finally, there's a short script sample. So, I mean, does this look like a real exploit attempt, or might this be a false positive instead? Because to me, it looks like kind of a false positive, because the source file is actually from a Chrome extension, and if you do the research on the script sample, it's actually Google Analytics. So we Googled this Chrome extension, and what we found is that this is actually coming from LastPass, which is a common extension that will kind of save your username and password and easily log you into some pages. And this actually turned out to be a big problem for us, because when we deployed this in production, we saw that we got a ton of false positives coming into our log files, and this was really a big problem because it made it difficult for us to actually filter them out and see the real true vulnerability that it's really the only thing that we want to know. So we're going to talk a little bit about what we did to filter that out, and I just want to warn you that we don't really have a perfect solution to this. This is just our research and what we've done, but it's in no mean a perfect solution, and I don't even know if there is one to this problem. So the problem here is that several sorry.
So do these error messages actually hinder the normal operation of the site? Does it just break something, or do they just...
No, they don't really break anything. It just makes it's difficult for us to filter out the false positives. So if someone had a true
apparently some JavaScript didn't get run, and if it's a false positive, you would think that it sort of didn't do what it's supposed to do.
So that would be the extensions. The Chrome extension or the Firefox extension might not work as intended.
Yeah, so I think in this example, if you try to use LastPass on our website, it's not going to work. We could whitelist that, but we don't. At this point, we haven't done that. But yeah, something is breaking, but it's not our code. It's whatever that extension is trying to do that broke.
How does that affect your user experience?
That's a great question. At some point, we may have to decide if that's a negative impact for our user experience. Do we want to whitelist these Chrome extensions? And that's not something we've done, and we haven't actually received, to my knowledge, any complaints about these happening. But yeah, I imagine whoever does use LastPass is probably like, darn, it doesn't work. And maybe they think it's a bug in LastPass, but it doesn't work.
But then again, if they're injecting code into our website or web page, we actually need to allow unsafe inline on our site, which would take away a lot of the big positives with our content security policy as well. So it's not a trivial solution. But anyhow, so many of the browsers actually use these extensions, and they inject JavaScript code. For most reasons, or for almost all reasons, probably it's actually a good thing. Like LastPass needs to do this in order to populate the username and password. And Norton identity protection, which is another one that we've seen a lot from, actually probably also has to do it to detect the malware. The third one is Urchin Tracker, which again is actually Google Analytics, which probably needs to do it. And this is something that's used by multiple extensions, but it probably needs to do it just to send back the analytics data. The last one is more interesting because it's actually JS Shell. It's a plugin that pretty much does whatever the Chrome developer tools does. It makes it possible to inject JavaScript code into your website to read the variables or basically learn more about your code. So that's being blocked as well, but we're not really that sad about that because people that do that are probably not up to that much good for us. So, so what we basically want to do is we want to try to filter out the noise while still being careful to not filter out any of the true positives that might be in there. So we don't want to introduce a way for someone to cover up a real exploit attempt. So we started we downloaded all our reports that we had and started going through them and look for some patterns. And what we really came up with was that we could combine some kind of keyword with a CSP directive, like the source file, and create signatures based on that. So here are a few of some common Chrome extensions that we've seen. It's LastPass, Firebug, Do Not Track Me. And as you can see, they follow a very similar pattern. They all start with Chrome extension, with Chrome Dash extension. So we want to take a stab at filtering out those extensions, and that will go a long way. It won't solve everything for us, as I'm going to show you in a second, but it will still take us a long way. And I mean, we do recognize that an extension could still be malicious and do something bad for the user. But if they install a malicious extension, we can't really do that much about it. Even if it's blocked on our site, it's going to execute somewhere else, and we can't really help them with that. So let's look at the different browsers here. So as you've seen, Chrome loads their extensions via URL calls. So it shows up as a source file. So we could easily create a regular expression that just checks if the source file starts with Chrome Dash extension. And if it does, we mark it as a false positive. We still log all of them, just we can actually keep an audit trail of it, but we can mark it differently so we can at least do some searches and filter out the false positives. Safari is very similar. They do load their extension in the exact same way, so we can just change the source file to Safari extension instead and filter out the Safari extensions. Firefox turned out to be a little bit more tricky because they don't load their extensions in the same way. So if you take a look at the code, the example down there, it's actually real from our logs as well. There's really nothing we can do here. There's nothing that gives it away that it's a Firefox extension. Yes, we could create a signature based on the script sample, but that would be very easy for the potential attacker to fake it and just have the payload start with this line and thereby bypassing our filter. So the Firefox extensions, we haven't figured out a way to actually take care of those yet. So that being said, I'm going to leave it over to Brian again, who's going to talk a little bit about the different issues we saw across browsers.
Thanks. So the final point we want to talk about here as we wrap up is maximizing coverage across browsers. As we mentioned at the beginning of the talk, for the most part, other than IE, the other major browsers, for the most part, do support CSP 1.0. So what we wanted to do was look at those 4 browsers and say, okay, within those 4 browsers, what are we specifically going to need to do differently to make sure that we're not breaking the user experience if somebody's coming from either an old browser or just due to some nuance on how that browser works with CSP. So the first and most obvious one, if you start researching things that people have run into with content security policy, is that for the most part, all of the browsers except one use the standard content security policy header. It's defined, I believe it's even defined in the spec. They've agreed to this header name. They did used to support some other similar header that was prefixed with an X, so X content security policy, but as of today, they all support content security policy, with the one notable exception of Safari. Safari still to this day uses its own content security policy header that is named X WebKit CSP. So at a minimum, we knew that based off of this behavior, we were going to have to do something potentially to figure out what browsers the user is using, because we can't just set one ubiquitous header and have it work across the board. So the first thing we thought of was, what's the best way to do this? Are we going to need to detect the browser? Should we just set both headers on every request, on every response? But the other thing we ran into was a lot of reports about older versions of Safari, and there's really nothing stopping this from happening with another browser that maybe we haven't even considered. But older versions of Safari actually had a CSP implementation that worked, but it didn't. So it tried to block content, but it basically would block everything. So you actually can't even set a content security policy header with those older versions because it pretty much just breaks the user experience. So what we decided was we were going to have to go ahead and do some level of browser detection and set headers specifically based off of what browser the person's using. And we looked at two options for that. One was using Apache's mod header, which was our preferred option, since we know that it covers every single request that comes through our web server. And just a quick side note, our architecture, while our app runs on Tomcat, we have it front-ended with an Apache server. So everything does go through Apache first, and then the app requests that get handed off to the Tomcat connector make their way to Tomcat. So the problem there was that we couldn't get, we needed to do some rewrite rules, some mod rewrite rules to get the browser detection working, and we just ran into a lot of issues chaining the rewrite rules to header rules. So what we did was we played around with a Tomcat filter instead, and we have numerous filters that we use already in our application. And even though that may not hit every single request, so if you get an Apache error page, for example, that's not going to get covered by our filter, it is going to give us a lot more flexibility. So we ended up opting to go with the servlet filter approach. So we have a filter that tries to identify the version of the browser that the person's using, and provided that it's able to identify it, it'll set the appropriate headers and make any tweaks that we need to make specifically for versions of browsers and so forth. So that's the one main thing that we had to do off the bat. The other thing that we noticed was going back to the error reporting, we kept on getting, so all of the browsers, again, with one notable exception, post a JSON object as the error report. Safari, however, sends an old name, basically like a classic name-value pair, like a post, with all of those name-value attributes instead of a JSON object. So what we found was that we had a bunch of exceptions happening that were triggered from our error reporting URL that were actually caused by Safari posting this data because it was expecting JSON. So we had to actually build in some logic there that actually tries to post it first as JSON, then if not, it tries to see if it's well-formed name-value pairs, and then worst case, last ditch, it'll just spit the data out to a log file somewhere, and we can look at it later if we want to figure out what it was. Back to the point originally, though, about the potential for abuse on these servlets, it is certainly a threat. You don't want to have any sort of heavy database logging going on with CSP error reports, because somebody can easily then potentially even carry out a DOS attack by just bombarding you with CSP error reports. So we use a very lightweight logging mechanism for this that doesn't even hit a database. And then the other thing that we ran into that we actually has been solved since we first rolled out CSP, but we still haven't even rolled it out into production on our app because for backwards compatibility, we're still able to use these old directives. One is, I mentioned before, Chrome and Firefox used to use X content security policy instead of content security policy, and Firefox used to use, instead of connect source, they originally were using XHR source. So all of the newer versions support the standard variants of that. We're still using these old ones, but we're going to phase them out over the next couple months here. And luckily for, again, backwards compatibility, the newer versions still support all of these older variants. So all of the dealing with Safari led us to kind of think about, why they do things a little bit differently. And then somebody pointed out that there was an ad campaign back in the 90s about Apple, and their slogan was "Think Different." So, we're thinking maybe that might lend some credibility as to why they're doing things differently. But I'm sure as time goes on, they're going to standardize. And again, to their credit, at least they're implementing CSP because some of those major browser families still don't even support CSP, even with the most recent versions, specifically IE11 still does not support CSP1. So That's really all we wanted to cover with respect to browser nuances. There's certainly a lot more that we could get into with more time on older versions, but I think that covers a lot of the relevant stuff that at least is applicable for applications today. And just to sort of recap, I think the three takeaways here are, first, CSP works. The bottom line is, even though browser coverage is spotty and it's still a 1.0 standard, with regards to XSS, it does work. You may not end up with a bulletproof policy, but you'll be better off than you would be with no policy. And then the last 2 points here, the error reporting, like we said, we don't have a solution, but it's very noisy. I think we'll see as time goes on, there may be some enhancements to that to eliminate that noise. And then lastly, 1.1, while it's going to be great, a lot more features, support's just not there yet. So I think if you want to play around with CSP, we recommend, for now at least, tinkering with the 1.0 components, at least to get started, and then later on 1.1 will become a little more standardized.